Hi, this is Azu, and we are going to start our notes for today. Go ahead and set up your notebook like this. Actually, let me take you to the table of contents here. You're going to do your notes in page 41. Go ahead and pause the video here to copy and update your table of contents. We're going to start our notes on page 41 in your notebook, lesson 2.2 in the textbook for you to reference if you need any help. We're going to talk about the distributive property. We are reviewing this property because you have learned it last year in elementary school. And so what we're going to do is continue to use the property to simplify our expressions. Now, in pre-algebra 7th grade math, we use a lot of variables. So that's what you're going to see today in your properties. Pause here. We're going to go to our PowerPoint here. Now you can see that this picture here is showing two people. They're holding boxes and they're distributing them. So this distribution property will actually give you an idea of what that means. So let's say, for example, and if you could please write this example into your notes under the goal. We have a bag, and inside the bag there are 2 lollipops and 3 Jolly Ranchers. So we say 2 lollies and 3 jollies. Now I do want 5 bags of them because I want to share them with 5 people. Now if I were to do that, I can express what I see here in mathematics as 5 times 2 lollies, and I'm going to add that with 5 times 2 jollies. Now the reason I use addition would be because I'm adding more and more, and I'm simply going to multiply that. I'm going to need 10 lollipops, and then how many Jolly Ranchers would I need total for 5 separate bags? Good, 15. So this expression here actually represents a distributive property where I could use variables, so 2 of the S's, suckers, and 3 of the T, so I just happen to use the variable S and T. And then I could simply write that as where I multiplied 5 bags that I want to have 2 Jollies in each of them. So I would do 2 times 5S, which is 10 S's, so to designate that it stands for the Jolly Rancher, the lollipops, and then 3 times 5 for 15S, and that would stand for my jollies. If I used just simple variables to represent a distributive property, I could say this, that A, any number, times B plus C, any number, would be A times B plus A times C. As you can see here, that if I want 5 bags of 2 jollies in each one, 2 lollies, I'm sorry, and 3 jollies, then I would multiply 5 times 2 jollies and 5 times 3 jollies separately. I think I keep saying the jollies and lollies wrong. Please copy this page and pause here. If you could also please copy this. This is the distributive property that you just saw with addition. Now we're going to look at it with subtraction as well. So when there is a subtraction, you would simply, instead of addition, in between multiplying A and B and A and C, you would use a subtraction sign. So let's look at a quick example. Let's say A was 3 and B was 4 and C was 5. So instead of using variables as letters that represent any number as fractions, or it could be expressions, numerical and variable expressions, we're just going to use these simple numbers. Of course, in order of operations, I could simply follow PEMDAS and do 4 plus 5 first to get 9, then multiply 3 with 9 to get 27. When I use a distributive property, I would do 3 times 4 and 3 times 5 separately, then add them together. So when I do follow PEMDAS after I've distributed the 3 with the 4 and the 5, then I could simply follow PEMDAS and multiply first. So multiply 3 and 4 is 12, multiply 3 and 5 is 15, then in PEMDAS simply add, and I would still also get 27. So it works. Now of course that seems like a much longer way, but Why would we use it? Well, if we have maybe a variable such as x and we don't know that it is what number that is, we could simply multiply 3 with x and 3 with 2 and get a simplified answer of 3x plus 6, because we can multiply the 3 and the 2 to get 6. Let's try a couple of examples. Try these 6. You may try them yourself if you are familiar, and pause the video here and then rewatch. Number 1, I'm going to simply multiply 5 with x to get 5x, and then I'm going to multiply 5 with 3, so I get 5x plus 15, and I simply leave it like that because I cannot add 5x with 15 because the 15 doesn't have an x, and they're not the same. One has a variable and the other doesn't. For number 2, we would continue to do the same thing. 6 times y, 6y. 6 times 7, which is, and then we multiply those, and we get 6y plus 42, and there we go. Now we're going to look at one with subtraction, 3 times m, and we're going to do 3 times 8, and we're going to keep a subtraction sign right there in the middle. So we're going to simply have 3m and a subtraction sign minus 24. Here are the rest of the answers. I hope that you got them right.
It's time to start
Another way that we could describe the distributive property is by using a geometric model. We will be exploring this concept in class, and so it's important that you're there in class so that any of the activities that we do to extend the concepts we learn, you'll be able to experience that with us in class. Otherwise, it is very hard to make some of those things up. Please also copy this in your notes. Here we have a rectangle. Now we're going to look at the area of this rectangle. We have the width side, that is 4. Down here it's 5. This length right here is 2, which means that the total length of the entire outside of the rectangle would be a 4 by a 7. There are 2 ways we can find the area of the rectangle. We could do it as a whole and simply, or do it as 2 different parts. Now the area of a rectangle, the formula is the length times the width, or the width times the length. So if we were to do this as a whole, we would multiply 4 times 5 plus 2, just like that. Or we could take it as 2 parts, 4 times 5, the area of that larger rectangle, and add it with the area of the smaller rectangle, which is 4 times 2. As you can see, they are the same, and you can work out the answer yourself, and you will see that you will get 28 for either finding the area of the rectangle as a whole or as 2 parts. Now this shows the distributive property, where I distributed 4 and multiplied it with 5, just like I did here. I distributed the 4 with the 2, just like I did here, and then simply added after multiplying, still following PEMDAS. I followed PEMDAS here, but decided to add the 5 and the 2 first before multiplying the 4, and got 28. So instead of using numbers, now I'm using letters, and we can see the area of the rectangle in terms of x, y, and z. So if I found the rectangle as a whole, then I would take the formula, which is the width times the length, or the length times the width. And again, because we're using the commutative property, whether it's length times width or width times length, we can switch the order of the numbers or the letters here, and it would still be the same. So as a whole, if I multiply x with y and z, so I would have to take both of those together, so I'm going to add them. So here you see me multiplying x with y plus z together. And as two separate parts, I'm going to take the area of the larger rectangle first, and the width is going to be that part, which is an rx, and down here at the bottom the length, which is y. So I would multiply x times y. Then I'm going to multiply the area of the smaller rectangle. The length here is x, and the width down at the bottom is z, which means I'm going to multiply x and z. So then I'm going to multiply x and z here and have that equals plus addition sign in the middle of them, because I want to add them together to find the area. And you will notice that they are the same given what we know about the distributive property. These are the end of your notes. Enjoy your day, and we'll see you tomorrow in class.